For my example, I chose the limit as x approaches 9 with the function square root of x minus 3 over x minus 9. This is a relatively simple limit. It just uses a kind of different, I guess, rule to be considered, which I'll explain here in a minute. But to always start with limits, when you're finding the limit, first thing you want to start with is the substitution method. So as limit of x approaches 9, so 9 is our a value, or I guess x value here. So we'll just plug 9 into the function. So square root of 9 minus 3, which is 0, and then 9 minus 9 is 0. That gives us 0 over 0, which is the indeterminate form. This is telling us that we're going to have to do some more work, and this will be the interesting method that I was talking about. So to find the limit, we're going to have to multiply this function by its conjugate. What the conjugate is in this case is basically the numerator, both its sign swapped. So instead of square root of x minus 3, we have square root of x plus 3. So when we multiply these two things together, of square root of x minus 3 and square root of x plus 3, we'll get x minus 9. And for the denominator, when we multiply x minus 9 and square root of x plus 3, we'll just take them and put them in parentheses underneath the numerator of x minus 9. We want to just put them in parentheses because the two x minus 9's cancel, leaving us with 1 over the square root of x plus 3. Now this is a function that we can actually work with to find the limit. And to do this, all we have to do is substitute 9 in for x. So we have 1 over square root of 9 plus 3, which is just 1 over 3 plus 3, or 1/6. That is the, in my opinion, easiest way to do this. Another way to do this is to find the limit by taking x values that are approaching x equals 9 and finding what the actual value is that they are approaching. So right here I have a chart for the negative direction, from the negative direction. I started with 8.9. You can start basically any number, but the closer you are to 9, the more accurate it'll be. So I started with 8.9, I went all the way to 8.9999, and as you can see, the value that we're getting is getting closer and closer and closer and closer to 1.66 repeating, which is equivalent to 1/6. And over here, we have the same exact type of t-chart, except we are approaching 9 from the positive direction. So I started with 9.1 all the way to 9.0001. And we can see that we are approaching the same exact number of 1.66 repeating. Down here, I wrote down the functions just from the negative and the positive direction of what we're approaching. And we can see that the limit as x approaches 9 from the negative direction of the function 1 over square root of x plus 3 is 9. And basically the same thing over here at the positive side. So the limit as x approaches 9 from the positive direction of the function 1 over square root of x plus 3 is 9. Using these two pieces of information, we can infer that the limit as x approaches 9 does exist. And in this case, it is 1/6, as we can see using these charts. Another way to do this is to use Desmos or a graphing calculator. So in other words, just graph it. And we can see what value of y we get at x equals 9, which is our limit. So I will start over here on the negative direction, and as we slowly approach, we can see that that number in the y value is getting closer and closer and closer to what looks like 1/6, but is actually undefined. This is that indeterminate form that I mentioned at the beginning of 0 over 0. But this is our old function. If we plug our new function into Desmos, and we do the same exact thing here, coming from the negative direction, we get closer and closer. We can see it's approaching what looks like 1/6. When we get to 9, we do actually get the value of 1/6. This is just another way of demonstrating how to find the limit.